Assalamualaikum, my name is Kalakini bin Asnul Feroizham. My number matrix is 2023-880274. Today our group will be presenting MAT183 project about application of differentiation related rates. What are related rates? Related rates are rates of change associated with two or more related quantities that are changing over time. Why related rates are used? Related rates help determine how quickly one variable changes in relation to another, which is useful in real-world scenarios, like a ladder sliding down a wall. By identifying the relationships between variables, differentiating with respect to time, and substituting known values, we can find the desired rate of change. This method is widely used in fields such as physics, engineering, and economics. For example, a spherical ball is being filled with air. Both of the radius and the volume of the ball are increasing. Arguably, the rate of change in the volume is related to the rate of change in the radius. In this case, dV per dt and dr per dt are related rates because volume is related to radius. This is the problem that we have to solve. The question is, oil is poured into a cylindrical container so that its surface area increases at a rate of 32 cm per second. The head of the container is 3 times its radius. How fast is the volume of the container increasing when the head is 30 cm?
Assalamualaikum. My name is Muhammad bin Subtopic. My student code is 202345838. And today I will be showing you the steps to solve the problem. Alright, so first of all, we'll need to read the problem. First, oil is poured into a cylindrical container so that its surface area increases at a rate of 32 centimeters cubed per second. Alright, from that we can infer the dA dt of this question. This equals to 32. Alright, the height of the container is 3 times its radius. Right? The h is equals to 3r. How fast is the volume of the container increasing when the height is 30 centimeters? Alright, from that sentence we can infer two things. What? First of all, the first thing is that we want the question wants the dV dt, and the height needs to be 30 centimeters. So we'll just plug that number in to find the radius. So 30 over 3 r equals to 10. Alright, now to get the dV dt. So we need to make our own equation, which is dAt times, let's say, dV dA. Alright, since we can cancel out the dAs and the dV dt will be the only things left. Alright, since we don't know what the dV is, we need to make another equation from that, which is dA is equals to dV dr times dr dA. Just like earlier, we only need to cancel out the dRs, so we get the dV and the dA. That's like the original solution. Alright, so now we need to find the dV dr. To get the dV dr, we need to first know the equation, the formula for the volume. Since we know it's a cylindrical container, the shape, the formula for the volume will be pi r squared times h. Since we want the dV dr, we don't want the h. We can use the equation earlier of the h is equals to 3r. So we can substitute it in this. to be pi r squared times 3r. So it'll be 3 pi r cubed. Right. And then to get the dv dt, we just dv dr in. We just need to differentiate the equation. So it'll be 9 pi r squared. My name is element. My matrix number is 2023454932. And now we need to find the value for the dv over dA. So we need to know that the formula for area for cylinder is A equal to 2 pi r squared plus 2 pi r h. Then from this, we need to just sub the h value with the 3r because we just want the value to be a d over dr. So we just substitute it and we get 2 pi r over 3r. And we need to evaluate this. 2 pi r squared plus 6 pi r squared. Again, we just need to add this and we get 8 pi r squared. To get the dA over dr, we can differentiate this equation. Then we get dA over dr equals to 16 pi r. We want the dr over dA. So we can just write it as dr over dA equals to 1 over 16 pi r. Then we need to find the dv dA. For dv dA, we know that dv dA equals to dv over dr times dr over dA. So for dv dr we get just now 9 pi r squared, and we times by dr over dA is 1 over 16 pi r. Then we need to times these two, we get 9 pi dv dA equals to 9 pi r squared over 16 pi r. And then we can factorize these two, and then we get 9 over 16 r. Alright, so this is for dv dA. Now to get the dv dt, you can substitute it to dA over dt times dv over dA. So in the question we get the dA dt is 32, then times the dv dA we get just now 9 over 16 r. This is for dv dt, and we substitute the r with 10. Sorry. Then we get 32 times 9 over 16 and 10. On this we get the dv dt equals to 180 is the volume over the time, so we write it as centimeter cube per second.
And hi, my name is Muhammad Arif Imran bin Azri, and I want to talk about the conclusion. So, in conclusion, we were able to solve a real world problem by applying the concept of related rates within mathematics. The problem at hand is an example of out many others that requires the application of related rates to accurately determine the increasing volume. As such, we were able to predict the outcome with absolutely certainty. For our references, we are using the Google Drive given by the madam at our Google Classroom. We are grateful for the references provided by our madam, as it contains numerous examples that greatly aid us in completing this task efficiently. The detailed explanation and illustrative examples in the references were invaluable, making the process much smoother and more comprehensible.